Welcome to Automated Visual Software Analytics. This part is about hierarchical circular bundle views. We will briefly outline principles of these bundle views, layout algorithms, and applications of circular bundle views in software analytics. Let's start with the underlying problem, the motivation. We would like to depict tree-based data. Typically, it's done using graphs, like in this illustration of a small tree. Leaf nodes are colored, inner nodes are gray. Leaf nodes have associated numerical values. These values could be any key performance indicator, any software metric measurement associated with a leaf node, for example, a file, a class, or a method or function. In this example, we can think of these values as klog, lines of code measured in 1,000 lines of code. So it would represent, in a way, the size of the implementation of this system that is represented by this small tree. So the question is, how can we visualize this tree data, and how can we visualize relations among leaf nodes of this tree data? The approach of the circular bundle view is to have a root node that corresponds to the outer circle and to map all child nodes by recursively nesting segments. The segments are proportional to the weights associated with the nodes. For example, child nodes having a big weight, for example, in this case, a leaf node with 40, gets a large segment. The nested segments also reflect the hierarchy. It starts outside from the root towards inside, ending up with the leaf nodes. Now let's extend this example by adding relations. Relations among leaf nodes. They are indicated in this diagram-based depiction by dotted arrows. And the question is, how can this kind of information be visualized in a more space-efficient, in a more compact way? It's obvious that once the number of relations become large, this principle of drawing arcs between related components has principal weaknesses because the layouting becomes extremely difficult and the links cross each other. The approach of the hierarchical circular bundle view is different. Based on these layout principles for the hierarchy, we have a hole in the middle of the ring, and this space is used to draw these edges that connect leaf nodes. We will explore this in detail. First, let's define what is a hierarchical circular bundle view. It defines a visual mapping of, first, a tree hierarchy to a ring structure with nested ring segments, whereby the segments are proportional to numerical weights associated with tree nodes, and second, relations between tree nodes depicted by banded lines which are positioned inside the inner ring. This is called altogether, the tree hierarchy and additional relations, a compound graph. So hierarchical circular bundle views visualize compound graphs in a very space-efficient, in a very comprehensive way. The layout is based on segments. So for each node of a given tree hierarchy, we get a segment, and segments of child nodes are contained in the segment of the corresponding parent nodes. This is a hierarchy visualization, the nested segment representation. And the relations are represented by lines We will learn more about this in the next slide. In summary, it's an efficient space usage in contrast to graph-based approaches because we can use that whole space, this inner ring, to represent the relations. So let's see how it works. How does the algorithm work in practice? Let's start with our sample hierarchy on the left side. We choose an initial ring that represents a whole tree. And now we recursively subdivide for the first layer of children at the children at the first depth layer of this hierarchy. Yeah, this is how the splitting looks like. The two leaf nodes having a weight of 12 and 8 get their segments. So as they are leaf nodes, they connect to the whole. And the other two inner nodes need to be recursively splitted. This is done next, where we split them too. We get these small segments for these leaf nodes having a small weight. And also this subtree is recursively splitted. Yeah, what one subtree is missing. This is done right now. And we end up with a recursively splitted ring. All leaf nodes connect to the whole. This structure also shows the hierarchy because the root starts outside and inner nodes are kept visible. These are the gray segments. So let's extend this example. We would like to visualize the relations defined in this component graph. We would like to draw edges. We could do this by drawing straight lines between two connected nodes. We ignore in this example the direction of the edge. Straight lines, however, would have low readability because small elements positioned near to each other are difficult to identify if they are connected, like in this case here. So we need a better strategy, and this is part of the hierarchical circular bundle view technology. It more or less mirrors the hierarchy into the whole. This is called a radial tree. So the root node is the center point of the ring, and each depth layer of the tree is one circle, and the children are placed according to the angle in the appropriate inner circle ring. These points, these black dots, are used just for layout, so they will become invisible in the next stage, but they are used as control points for banded lines. A banded line is implemented by a Bézier curve, a banded graphics primitive known in computer graphics. And this banded curve is defined by an end and start point together with some control points that shape the banded curve. Yeah, if we do use these points as control points, we get banded lines like this. The bending respects the hierarchy position of the involved components. So if, for example, siblings are connected, like in the case of these two leaf nodes, their banded line is close to them but does not cross any other hierarchy levels. So this is one of the working principles of circular bundle views, that the banded lines that show relations respect the hierarchy. So it becomes easier for the user to perceive and recognize these relationships. Yeah, this is how the result looks like. We can easily identify these relations drawn here. However, they are not directed. This could be added, for example, by an arrow symbol or by a color scheme. Yeah, the final layout bundles banded lines implicitly by the mirrored points of their lowest common ancestor in the tree hierarchy, and helps this way to depict relations between small items that are located nearby. What are the applications of hierarchical circular bundle views in software analytics? Of course, software engineering data is, generally speaking, organized by hierarchies. For example, the system implementation hierarchy, files, classes, functions, methods, namespaces. Even the runtime data is organized in a hierarchical way. For example, execution traces with a call graph show a hierarchy, or even the development process involves hierarchy data, for example, the development team and its organization. So we have a strong need for visualizing hierarchical data in software engineering. However, there is also a strong need to visualize relations that are defined among components of hierarchies. And in this case, the hierarchical circular bundle view is very powerful. It helps to depict relations among components of hierarchies. The edges used to represent relations are banded and can be bundled. The visual mapping of relations this way scales in a sense. That is, even if we have a large number of relations, they can be close to each other and bundled according to their hierarchy position. So the bundle view is able to visualize even large sets of relations. Examples of typical relation types visualized by bundle views include dependencies between modules, call dependencies, or deployment dependencies, and many other types of relational data in software engineering. Yeah, to give you one example here, it has been used, the hierarchical circular bundle view, to depict modules dependencies. So green means this module uses another module, and red means this module is used by another module. We can easily detect just by looking at it that this blend kernel module is used by many other modules, and for example by this big one. In this example, you can also see how segments of a bundle view can be extended to a third dimension, which may be useful to visualize additional information associated with segments, for example, their code complexity or their implementation size or any other attribute that should be visualized together with the relations and the hierarchy structure. In this example, for example, the lines of code measures are mapped to height, so high segments indicate large modules, and the code complexity is mapped to a green, yellow, red color scheme. Yeah, of course, in this example, we can interactively explore different relation types. This is a typical task of software analytics, to work with these interactive representations to find out more about a specific situation, to identify trends and patterns in relation data that is defined among hierarchies, etc. Let's summarize. To map hierarchical data together with relations defined among their components, hierarchical circular bundle views provide a space-efficient visualization approach approach for compound graphs. The edges which represent relations can be bundled and reflect the hierarchy setting. So this kind of visualization provides context and facilitates identifying and exploring relations within a hierarchy. In visual software analytics, hierarchical circular bundle views are one key instrument to explore, analyze, and monitor compound graphs, which are common for complex big software engineering data. Applications of hierarchical circular bundle views in software analytics also include examining, analyzing, and comprehending inheritance relations, function call relations, and of course module dependencies. Yeah, this concludes this part. Some terminology. Compound graph is one expression that is frequently used in graph theory, for example. It defines a hierarchical structure, such as a tree, with a set of relations between its leaf nodes. The hierarchical circular bundle view defines a visual mapping of a tree hierarchy to a ring structure with nested ring segments, whereby the segments are proportional to numerical weights associated with each tree node. And second, a visual mapping of relations among leaf nodes represented by banded lines, which are layouted and positioned in the inner hull of the ring. The term edge bundling refers to a rendering technique that provides a compact layout for banded edges to ensure visual clarity if the number of relations becomes large. Yeah, some further reading. We can recommend this paper about hierarchical edge bundles, visualization of adjacency relations in hierarchical data, from Danny Holton, appeared in IEEE Transactions of Visualization in Computer Graphics. Let me give some remarks at the end of this part. Like tree maps, hierarchical circular bundle views and software engineering data are a good team. Why? Compound graphs are frequent, and these bundle views are effective means to visualize them. Bundle views have one big advantage. They have an effective layout for relations, the edge bundles, in contrast to many graph-based visualization approaches, as there is an explicit area, the hole in the ring structure, that allows us to reach all leaf nodes of the hierarchy. So the complexity of the layout is reduced, and it's space efficient even for large sets of relations. Bundle views can also be used interactively to edit relations by moving leaf nodes, by reconnecting edges or edge bundles. This is a high-level approach to the management to edit relations among hierarchy nodes. Can be used, for example, in the scope of refactoring a system to try and find out what components are affected and how they could be moved in new sub-hierarchies if in real time the bundles are updated within the bundle view. Technically, the rendering implementations allow for visualizing large hierarchies in nearly real time. That is, they can cope with big data sets as well.